we'll ask Jay Famiglietti to come up and give us a talk. Jay is a professor and a JPL senior water scientist at Caltech, and he's going to talk to us about 21st century water security as viewed from the NASA GRACE mission, which I'm sure most of you are familiar with. So, Jay.
Hi. Thank you, Al. By the time we get this paper published, it might be the 22nd century. So thank you, Howard. I realize it's your symposium, right? So like you have to sit there the whole time. You can't just get up and leave. Okay, so I want to talk about some of the work that we've been doing with the GRACE mission, and in particular defining water security and what are we seeing from satellites like GRACE, what are they telling us, what are the implications, and what should we be doing as a community. And here, we're already seeing a tremendous amount of very exciting research. I want to talk a little bit more about communication as an important bridge to policymakers and to stakeholders. So water security, if you think of, so I wrote a definition for water security for a proposal, and it sounded like Claudia's definition, so I was glad to see the definition that she showed, and it goes something like this. A region is water secure if it can provide a reliable supply of potable water to its population for its various uses, water for food, water for the environment, water for people, for energy, for economic growth, both now and into the future, considering things like population growth and climate change. It was maybe not the best definition because the proposal was rejected, but I still use it. And we also have to consider things like changing extremes, right? The political climate in a region and in neighboring regions, and we have to be concerned about protecting water supplies now, so actual security, now that we have to worry more about terrorism these days. So it's a simple definition, and when I think about sort of distilling it down to sort of the physical side of things that we work on in my group, it sort of gets to how much water we have, meaning how much fresh water do we have, how much is renewable, how much is in groundwater, what's the total amount, and how much do we use or need, which are sort of two different things. How much we need is probably less than how much we use. So there's a social, right, economic, political side to that. And how is that supply versus demand gap changing over time? So I will focus on the bottom line, the how much do we have, and really sort of how much we have and how it's changing over time. And so to do that, we've been working with the GRACE mission. GRACE stands for Gravity Recovery and Climate Experiment. Since before its launch, we started working on it in 1995 or 1996 with Matt Rodell's dissertation. It launched on St. Patrick's Day in 2002. The orbit is, so this is for the three people in the audience who don't know about the GRACE mission. I'd like to sort of set the stage. So orbits at about 400 kilometers, because the rest of the people who've heard this talk have heard this about 5 million times. The two satellites are separated by about 200 kilometers. They're not very big, as you can see from this picture. I like to say that it works like a scale in the sky, and that as the two satellites are in a tandem orbit, they follow each other around in a near polar orbit. And so when they fly over a region that's gained a lot of water, say because of the snowstorms, if the snowstorms across Saskatchewan were a little bit heavier, the region would gain a lot of water mass, and the region would exert a slightly greater gravitational tug on the satellites as they fly over. Likewise, if you fly over, when the satellites fly over a region that's lost a lot of water, say like California where I live, because of the drought, then that region exerts slightly less of a gravitational tug, and the satellites float a little bit higher in their orbit, and the distance between them changes. So by keeping track of the ups and downs and the horizontal movements of the satellites, we can actually map out the places, the regions around the world that are gaining or losing water mass on a monthly basis. It measures the change, right? So it's the delta, it's not the total amount of water. In the total water storage, all of the snow, the surface water, the soil moisture, the groundwater together. If we want to just isolate groundwater, and we've done some of that work, you need information on the snow, the surface water, and the soil moisture so you can subtract it out. So it works on longer time scales, monthly time scales, larger regions, 150,000 square kilometers and greater. So it's really much more about hydroclimatology than it is about hydrometeorology. With an accuracy of about 1.5 centimeters equivalent water height. If you took the equivalent water and spread it on the surface, the signal would have to be greater than, the change would have to be greater than 1.5 centimeters to make the satellites move. The GRACE mission actually is just decommissioned. So I guess the official decommissioning was when the last satellite entered back into the atmosphere, which was not that long ago. It was just a couple of weeks ago. But sort of preliminary decommissioning happened in December. But the follow-on mission, called the GRACE follow-on, will launch at the end of April. And it's almost exactly the same mission. So we hope to have just a short gap in the GRACE data. So just to give you a look at what some of the data look like, this is almost the complete time series for the area for sort of a grid that sort of down here in southwest Saskatchewan. And so what we're looking at are the monthly ups and downs of the total water storage starting in 2002. This goes through about the middle of you did? Okay. So look, things really started looking up. This is called the Weeder bump. Yeah. Yeah.
We call that the Weeder maximum.
Yes. So anyway, that's what some of the data look like up north. And I'll show you some images that show that all across the north we're seeing a lot of gains in water storage. But if we go down to where I live, in California, it's been much more bleak, and we have been in various phases of drought for the last 10 years. This is a look at what the groundwater situation looks like here in the Central Valley. So the Central Valley is this part here of California. And it's, like Saskatchewan, heavy food producing region. The Central Valley is the blue part here. These are the major river basins, the Sacramento, the San Joaquin, and the Tulare Lake Basin. So we've done a lot of work sort of isolating the groundwater signal from the GRACE signal. This is our latest time series. This was the last winter. So this is the 2006 to 2010 drought, then 2011 or 12 to 2015, 2016. We had a little recovery, and this is sure to just flop over now because we're back in a drought. So we can quantify things like how much groundwater depletion there is, and of course most of it's related to agriculture. The bigger picture is that this is something that's been going on, not just in California, but in a lot of the world's major aquifer systems for some time. So this is a combined figure that shows USGS data going back to 1962 in the Central Valley, and GRACE data here. The colors in the background represent whether it's a wet period like the brighter blue, or a dry period like the tan, or the variably wet to variably dry, sort of moderate, the light tan and light blue. And so, the picture here is one of continuous depletion. That there's some recovery during wet periods, but the declines during drought are much greater, and you can see that, right? You can see that here. So it's one step, little recovery, another step, and so that's sort of our behavior. And so, in terms of communication, I've done a lot of work on messaging, what's happening here and what the long-term prognosis is and why we need to have better measurements and do better groundwater management if we want to sustain agriculture. So let's look around the rest of the world. There's, we think, a climate change component to what we're looking at here. So this is a trend map from the GRACE data for about the entire period, almost the entire mission life, so about 2002 to 2016. And the blues are losing water, and the blues are gaining water, sorry. And so blues are getting wetter and reds are getting drier. And so the climate change part is that, we're seeing the wet parts of the world, the high latitudes and the tropics getting wetter, and the dry latitudes, the dry mid-latitudes getting drier, and this is something that's, of course, been predicted by IPCC models. This is predicted precipitation patterns, same color scheme for the end of the 21st century. And so we asked the question if, we're seeing this now. Well, we're certainly seeing it. This is a paper that we published in 2016 that shows the dry area is getting drier and the wet area is getting wetter. Whether or not it's a climate change thing, we'll have to wait and see, but it certainly agrees with those patterns. So we've also done a lot of work. This is the paper I was kidding about being published in the 22nd century, but actually it should be out in a couple of months. So we've actually done a work looking at all of these trends. So these are sort of the climate trends, so ice sheets melting and glaciers melting away and high latitude precipitation increases. And there's a fair amount of interannual variability that shows up mostly in the blue spots. So a lot of flooding on almost every continent. And then there's sort of the human groundwater depletion. So a lot of these red spots here, Central Valley, High Plains Aquifer, Middle East, Arabian Peninsula, Caspian Aral Seas, India, Bangladesh, North China Plain, Northwest Australia, the Huarni Aquifer. A lot of those are being depleted. This is a paper from Sasha Ritchie's dissertation that took those data and mapped them to the aquifers and looked at things like groundwater stress. And the bad news there is that over half of the world's major aquifers are being depleted. We said they were past traditional sustainability tipping points, and that we're using more water than is recharged on an annual renewable basis. Here's some of the time series for those mid-latitude aquifers, and of course that's problematic because all of those support the major food-producing regions of the world. So as we know, food security, water security, energy security are intimately linked. So what are some of the implications? Well, for food, basically we're in a state of chronic water scarcity in these major food-producing regions, and that's why we have those red spots. So we're looking at sort of a chronic overdraft. And drought just makes it worse. The work in California certainly exposed that to us firsthand, and it's important that we recognize this. Because in some of these places, especially the mid-latitude places, it's not going to change unless we impose better management. So this is where the communication comes in. I think that there's a lot of solutions for metropolitan regions. We've seen it in California with desalination, with sewage recycling, with conservation, with pricing. But food, we just use so much more water, and a lot of the irrigation water comes from groundwater. It's poorly managed. So I think we have issues here, and I see a future where either we're going to be moving water to the water scarce regions, or to grow food, or move the food production to places where there's water, or somewhere else on the spectrum. And in California, we're seeing people move to southern Idaho, to Florida, basically move out. And in some regions, the U.S. is a good example of this. We grow most of our food in the central part of the country and in California, and we try to do it with water just from those regions. But we're supplying food for a whole nation, but we don't recognize it as a national problem. And so that we send a lot of food. We send a lot of food here. And we send a lot of food around the world, but we use just water from, say, in California, just water from the Central Valley, a little bit from the Colorado River Basin, only 10%. So there's some societal implications. I think we're living in an era of rapid climate change. And with it, we're seeing changes to the water cycle. We talk a lot about the extremes, and stationarity is dead. I don't think we're really, society, when I say we, is really prepared for the water, the food, the energy future that some of these slides and these figures from the GRACE mission suggest. and that population growth will only exacerbate because we're seeing the haves and the have-nots emerging, right? So we've got the wet area is getting wetter, the dry area is getting drier. So, right, in places like Canada, you have a lot of water, but you also may be, because I'm moving here, may be seeing more extremes, right? So longer droughts punctuated by more intense rainfall. So just because it's wetter doesn't mean it's better, but in a budget sense, there's certainly more water at the high latitudes. So there's the haves and have-nots sort of geographically and also in a location where the water table is falling. In California, the water table is down about an average of 2,500 feet in the Central Valley, and that's about a $250,000 well, which the average person can no longer afford to drill. Okay? And there's a 1 to 2 year wait, and that's just going to get worse as the water table falls, right? And the drought continues. So are we really prepared to address some of these social inequities, the potential we've just heard about, the potential for violent conflict, climate refugees, the revisions that we need? Eric Wood was saying before, it seems like the Cape Town stuff is just, mostly political. It's true. There's a lot of water rights that need to be revised. I know in the U.S., certainly in California, most of that stuff was written when we were still worried about bear attacks, right? Okay, thanks for that. Thank you. It was dark out when I came here and interviewed. It was just dark all day. Anyway, glad somebody left. And the need for, I don't think we have this sort of global political infrastructure in place or even regional agreements, and certainly they don't include groundwater. So most of the transboundary international agreements are about surface water, very few about groundwater. So we really need to start thinking about that. Let me just finish up with a few slides, mostly on communication. Again, what we do as a community, the research stuff, we know what we need to do. We're doing a great job. We've seen just a bunch of amazing presentations. But there is a gap between what we're doing and getting people to understand the action that needs to be taken. Why is it that in Cape Town, where it's being messaged every day that they're going to run out of water, there's no water left in the reservoirs, people are not conserving, right? After 5 years of drought in California, it took about 3 days of rain for people to just turn on the sprinklers again and start washing the cars and just going back to their old, more water-rich habit. So it's I think it's really a social science problem to really, in part, to make that connection. I used to think this. I used to think that once people really understand the source of their water supply, the sources and how they're changing, then the acceptance of the need for action and protection is far more likely. So in other words, again, in California, if you look at a wet year versus a dry year, if you look up at the mountains, you don't see any snow. Some of these images that I've shown were very, very powerful during the drought, very convincing within the state that we had a problem. So people can see this in the news, and we were talking about, I think Pat, you were talking about the bathtub ring. So you would think that if people see all this, then they would really appreciate the need for long-term conservation. But we know that's not the case, given those examples I just gave in Cape Town and in California. So just a little bit on communication. So for me, communication is a big deal. I engage my students in it. This is Brian Thomas and Jamiat Nteza and her daughter Haviva in Uganda. This is Stephanie Castle doing an interview at UC Irvine, and this is JT Rager doing a local drought workshop. So we don't want to communicate. I mean, wrote for Jeff, actually for AG, wrote what do we call it? Strategic communicate. Was it a strategic? Strategic was in there, workforce was in there, and communications was in there. A report by the workforce on strategic communications for the hydrology section. And the point is, communication is important, but you have to know what and why you're doing, right? Why are you doing it? What are your goals, right? Do you want to inform society? Do you want to educate decision makers and affect policy, right? Then who are the targets? Are they the agencies? Are they elected officials? Is it the general public? You have to know. And then what is your message? So it's important to know what, of course, what and why you're doing it. And some closing thoughts. I personally feel that we have nothing to, our niche is the very high quality peer-reviewed research that we do and that we've been hearing about for the last couple of days. So without that, we should probably, we don't have much to communicate. So assuming that we keep up the good work, then if you want to take that extra step, know your goals and get training and develop a strategy and certainly build experience. Okay? You can do all the training and workshops in the world, but it's probably more important to get on a plane and go to Ottawa, or if you're in the United States, go to DC or go to your state capital. I think that it's really a responsibility of us, we in the universities. I think we need to engage the public and decision makers and elected officials. So some people think it's a nuisance. I think it's a responsibility. There are issues, of course, with time and young people getting involved and not getting rewarded for those efforts. Students, my students pushed me to get involved, and that's how I got involved. I think as a community, we need to rally around some fundamental known unknowns. Right? Other communities do it, right? The ice sheet community, they look at Greenland, they look at Antarctica, and they come up with one number, right, they do a lot of other stuff, but they come up with one number for, right, the rates of ice sheet melt. And we don't do that as much in hydrology, right? So, knowing how much water is in a particular aquifer or a particular watershed is pretty important, and actually in many of the world's major aquifers, we don't even know. And I'll just finish with this one. I don't think, let me see if there's another slide. No, okay. So this is my last point. It's the food industry that, we always say agriculture, right, uses most of the water, sort of 80% of the water that's withdrawn is used for agriculture. But that translates to the food industry, right? And so we're probably not going to make a huge impact on food security unless we can start to partner with the food industry. And there are lots of companies that have embraced it and are willing to work with us and have a very strong environmental record. And so, I think we'll do much better if we get on a plane and go to Ottawa with, an executive from a big food producing company than we would if we just walked in on our own. We should still do that, but we need to engage the food industry. So I will finish right there. Thank you.
Thanks very much, Jay. That was great. Really like your thoughts at the end there. Being involved in government and policy, we see this all the time, so that's wonderful. So Jeff, you had a question?
Yeah, Jay, great talk. I think on the known unknowns, there's an effort coordinated by IHS, AGU, and EGU, led by Gunter Bloschel, and it's focused on unresolved questions, or effectively unknown knowns. That's kicking off at just after EGU, and this is going to unfold over the next year. So I think there's some.
Yeah, that's great.
There.
Yeah.
Quickly on Cape Town, I've been traveling, so I don't know all the details of what's unfolding, but I was there around 2000 on a mission for the International Atomic Energy Agency, and the focus was Cape Town's running out of water. What are we going to do? And the question was, could they use isotopes to see whether or not the groundwater is connected to the surface water, because their supplies were all surface water in the Table Mountains. And the question was, if they pumped the groundwater, would they rob Peter to pay Paul?
Yeah.
So all this is going on. My understanding is that they got so good with water savings, they kind of lost track of the need to develop other water resources. And I'm just wondering if you have insight into some of the particulars of the problem.
No, I really don't. All I really know is what we read in the newspaper, and so it's, pretty severe drought, population growth, climate change. There seems to be some finger pointing at a lack of preparation. So I hadn't heard about the scenario that you mentioned, but certainly heard, and Pat was saying, people have been messaging about this for a while. So there's a social side to it, right? That I don't know how we crack that. I don't know how we crack that nut. I really don't.
Okay. Any other quick questions? Okay, we'll take one more.
Thanks, Jay. Yeah, so I guess this almost wraps in with what Jeff had said in the Cape Town example of what's connected to what. So I guess it's always bothered me, and maybe this is kind of a known unknown in the hydrogeology community, right? We know that recharge is a pretty blunt instrument to assess, whether withdrawals are sustainable. There's that whole debate about how that relates to well hydraulics and capture and letting Conoco and other from the USGS have done those. Have you given that any thought or have any insights in how to reconcile that?
Well, I forgot, Jeff, to respond to that part of your question about the robbing Peter to pay Paul part. And so the issue, it's very clear in California that, and you saw it in that longer term figure, but I have a figure that just spans the grace time period. And the groundwater depletion, the use of the groundwater, basically, it's a surrogate for the surface water. So when we manage the surface water, the groundwater disappears. When we have a lot of surface water, the groundwater recovers. I mean, that's fundamental, right? But to message that and get people to do something about it is because it's a zero-sum game, of course, when you look at the total. But getting people to look at the total budget is difficult because they're spread across different agencies.